All right, guys. So today, what we're going to do is we're going to review some of that stuff we were doing towards the end of the year last semester. Sorry, not. Well, I guess it was a year too. We're going to go into some naming and just practice with naming. So we're going to do this first part together. So if you guys want to open it up, there's not really a bell ringer for you today. I know it says bell ringer. Today, we're not going to do one just because we'll start up again on Monday. So we're going to go right into that review for naming. So we're going to do this first page together, and then I'm going to give you some practice problems to do on your own for your assignment / homework for today. So we're going to look at ionic compounds first. So we need to remember what an ionic compound is. Does anybody remember anything about ionic compounds? Nothing?
Wait, I think I remember.
All right, what do you know about them?
Hold up. Give me 1 second.
Mm-hmm.
Give me 1 second. Ionic compounds. Nope. Never mind.
That's all right. So do you guys remember the word ion?
Yeah.
What is an ion?
A negative charge.
A negative charge. Great. That's half of it. It's not always negative. We can also have the other one, which is
Positive.
Positive charge. We have positive or negative charges, and that's when we gain or lose electrons. And so ionic compounds, we have two or more elements gaining or losing electrons so they fill their octet. All right, so that's kind of generalizing what an ionic compound is when we have two or more elements that gain or lose electrons. So the electrons are being transferred in this case. Electrons are transferred so that they have a full octet, which just means they each have 8 valence electrons. When we talk about ionic compounds, we need to remember that it's always a metal and non-metal. Almost always a non-metal. We're going to actually get into times when it's not just a non-metal, but a polyatomic ion, something we haven't talked about yet. That's what our first part of this unit is going to be on. So more specifically, we're going to change this. Instead of before we just said metal and non-metal, I'm going to change this to say cation and anion. And those are two words I'm hoping you guys remember. And let's remind each other what cations and anions are. Do you guys remember what those mean? Well, let's first look at the root of the word. So this part, the ion. So these are both types of ions. We have two different types of ions. You guys have already told me what two types of ions we know. So one of them has to be a positive ion, and one of them has to be a negative ion. Which one do you think is positive? Which one do you think is negative?
Cation is positive and anion is negative.
Awesome. There we go. So positive ion. And so this one is our negative ion. And then let's remind ourselves, positive ion means did it gain electrons or did it lose electrons?
Lose.
It lost electrons, which means a negative ion has done what with its valence electrons?
gained.
Perfect. All right. Is this ringing some bells? Do we remember it a little bit more from last semester now?
Yes.
All right. So that
Yep.
one yes. Perfect. 2 yeses means we're good to go. So now we have to remember how to actually name and write the formulas for these ionic compounds, because that's something we're going to actually have to do the rest of the semester. So that's why we're coming back. We're starting with it over again just to give ourselves a refresh. So we're going to look at these 2 elements. So the first thing we want to notice is that it says calcium chloride. And if you look at your periodic table, you're not going to find the element chloride. What you are going to find is you're going to find chlorine, and that's because we had to change the ending to IDE. Do you guys remember doing that last semester?
Yep.
The second element always gets its ending changed to IDE. So I'm going to make a note, and let's pick a different color. Ending is always IDE. So we're always changing it to IDE when we find it from the periodic table. And that's that second half, when we find it on the periodic table, is going to come into play when we actually talk about the stuff next week with polyatomic ions, because those ones are actually a little bit easier to figure out just because we don't have to change anything. They just show up and we write down what we see. The next thing we need to remember is that we don't change much else with the name. So if we're looking at this one, we have calcium. So the first thing we need to do is figure out the element symbol for calcium. What is the element symbol for calcium? Anybody know? Anybody have a guess? We can look at our periodic table. Maybe that would help us.
Isn't it CO?
Not CO.
L.
Ca.
Oh, Cl is chlorine, which is perfect, and Ca is calcium. We have them both now. We don't need to worry about going back for now. So we have calcium, which is Ca, and we have chlorine when it changed it back to its original name, which is Cl. When we're talking about ionic compounds, we're worrying about the charges. So we need to look at the charges. So we have to figure out the charge of calcium and figure out the charge of chlorine. So how many valence electrons do they have to gain or lose to get to 8 valence electrons? So calcium has how many valence electrons to start with?
Two.
Perfect. It has 2 valence electrons, which means if it wants to get to 8, are we going to have a positive 2, a negative 2, a positive 6, a negative 6? Are we gaining or losing electrons, and how many electrons are we going to gain or lose?
Losing 2.
Losing 2. So we're going to put a 2 up here. And you guys said before that it's a positive ion if we lose electrons, which means it's going to be a positive 2 charge. Chlorine has how many valence electrons at the start?
7.
7. Awesome. So chlorine has 7. It wants to get to 8. How many valence electrons is it going to gain or lose?
It's gonna gain
This
1.
one doesn't gain.
It's going to gain 1. Perfect. Which means that we're going to have a -1 because you guys told me it's a negative ion if it gains electrons. So now when we're writing this formula, the last thing we have to worry about is we need the charges to equal 0. So they don't add up to 0. So these two right now have to add up to 0. And if they don't, that means we have to bring in more of one or more elements. So right now, if we add those two numbers together, are we going to get a charge of 0 for this formula?
No.
All right, so what do I have to do? Do I need to add another chlorine or do I need to add another calcium?
Another chlorine.
Awesome, we're going to add another chlorine. So I'm just going to put a second chlorine right here. So I have 2 chlorines and 1 calcium. Do my charges add up to 0 now?
Yes, sir.
Awesome, which means now we can write our final answer, our formula for calcium chloride. So we're going to have 1 calcium. And if you guys remember, we don't have to put the 1 right here because if we just write the element symbol, that shows me there's 1 of them. And then next to it, we put our chlorine. And we have 2 chlorines, which is where we get that subscript of 2. And this is our final answer for that first one. Is everybody okay with that? Sweet.
Yep.
Awesome. So now our second one, we're going from formula to name. So we got to go the other way around. So our first thing we want to do here is figure out what are these elements. So what is this element?
Potassium.
Potassium.
And what is that element?
Nitrogen.
Nitrogen. Perfect. All right. We have to do 2 more things when we're going from formula to name. The first one, which I think is a little bit easier, is to remember that we're always going to take the ending of our second element, that non-metal. If it's from the periodic table, we take the ending and we change it to what 3 letters?
IDE.
IDE. Perfect. So it's going to be nitride instead of nitrogen. The second thing, which sometimes is easy, sometimes it makes it a little more difficult, is we have to look at that first element. Is that potassium a transition metal? Is it in groups 3 through 12?
It's not a transition metal.
It is not a transition metal because it's over here, which means that we don't have to do anything else with it. We can just rewrite potassium as is. So we'll just put potassium. And this is our final answer, potassium nitride. We're going to do one more ionic compound. And so this one might be a little bit more difficult. So let's take a look. Let's first identify our 2 elements we have. So what is Cu?
Copper.
Copper, awesome. And what is S?
Sulfur.
Sulfur. What's the first thing we're going to do?
Change sulfur to
To what?
sulfide.
Awesome. We're taking the ending. We're changing it to IDE. So we have sulfide. Perfect. What's next on our list?
And check if copper is a transition metal.
Is copper a transition metal?
Yes.
Yes.
It is. And what's special about transition metals? Do you guys remember?
Transition.
They're the transition metals. Okay, so then if we look at those, if we remember those valence electrons are the reason we figure out how these ionic compounds work, because we have to worry about the charge that each one has so we can balance those charges. Well, copper, we can't figure out copper's valence electrons like we do normally. So we have to check our ion sheet, or when we're writing this in formula form. But for this case, we don't have to worry about our ion sheet. We just have to figure out what the charge of each of our elements is. So we have to worry about the charge because copper has two options. So it could have one valence electron or it can have two valence electrons. So we have to figure out which one we're dealing with, which means we need to know the charge of each of those coppers and the sulfur. Only one of those we can figure out from the periodic table. So we have copper or sulfur. Do you know the charge of copper just off the top of your head, what that charge would be? Or do you know the charge of sulfur based on the periodic table? Which one can you figure out easier?
Sulfur.
Sulfur. Okay, so we know sulfur is right over here. It's number 16. So we're looking at sulfur. And we need to figure out the charge on this sulfur, which means we want to know how many valence electrons it needs to gain in order to have 8 valence electrons. So what is my sulfur's charge going to be?
Adding 2 or negative 2.
We're gaining 2, which means it's going to be that negative 2. So we know that this is a minus 2. And what else do we know about charges on our entire ionic compound? What do we know our charges have to do?
They have to equal 0.
They have to equal 0, which means that these two coppers, which have to be the same number, have to add up to balance out this negative 2. So those two coppers combined have to have what value?
1 and 1.
1 and 1, so they can add up to a 2,
0.
add up to 0. So now we know our charge on our copper. And this is the trickiest part. If you remember copper then, since we know it has a positive 1 charge, we have to put the Roman numeral 1, which is an I or just a line. And that will be our final answer. Hopefully this is ringing bells a little bit. We'll do some practice with it. Don't worry, no test is coming up where you need to remember this tomorrow. You have some time. But we do now have to talk about covalent compounds. We know ionic compounds have to do with charges. We know that they're gaining or losing their electrons, so their electrons get transferred, and it happens between cations and anions, or metals and nonmetals. Covalent compounds. What do we remember about covalent compounds?
The two nonmetals.
2 nonmetals, perfect. So we're starting with nonmetals. What else do we know? One more big thing I'm hoping you remember. And let me give you a hint. The ionic compounds, we needed to remember that electrons got transferred. So what happens to the electrons in covalent compounds?
They're shared.
They're shared. Awesome. There we go. So they're shared between the two elements. So that's the big differences between ionic and covalent. Ionic, we have to worry about charges, and we're worrying about the transfer of those electrons, and it's metals and nonmetals. Covalent, it's all nonmetal, so it's all just the right side of the periodic table, and it's only sharing electrons, so they're creating those bonds by sharing their electrons. Each one is holding on to both. Now, when we're going to the name, it does make it a little easier for us because all we need to do is know our elements and we need to know prefixes. So for covalent compounds, we add prefixes. So first, let's identify, just like before, we identify our elements. So what is N from the periodic table?
Nitrogen
Nitrogen
and oxygen.
and oxygen. All right. The next thing is going to be the same step as ionic compounds, and it's going to be we're taking away the ending of that second element. And what did we change it to?
IDE.
IDE. So we have oxide right here. Now, our next step is different from the ionic compound now. What we do is we need to take those numbers and we need to create prefixes to represent those numbers. So the prefix for 3, does anybody remember that prefix?
Isn't it 3 lines?
So that's for Roman numerals, that
Oh.
is just 3. But the
I'm
prefix is the letters that go in front of the element name. So if we think of like an octagon has 8 sides, the
Tri.
Perfect, tri. So tri goes in front of nitrogen to create trinitrogen.
It's light.
Does anybody remember the prefix for 7? This one's tricky because tetra is a great answer, but that's going to be 4 is tetra, which is awesome. Good job on remembering those prefixes. This one's probably the trickiest one because the one that people never really use. So it's going to be, do you know it, Felix? You look like you Hepta, perfect. So hepta is going to be our prefix for 7. So HEPTA for hepta. Next to that O, the A does go away. So it's just going to be hept. So heptoxide. So we're going to have our answer as trinitrogen heptoxide. We got one more example problem to go through, and it's nitrogen monosulfide. So first thing we're going to do here is we need to identify each of these elements. So nitrogen, what is our element symbol for nitrogen? N, perfect. So we have N, and we have monosulfide. What element comes from this section? What element are we looking at? What is it?
Sulfur.
Sulfur, perfect. So this is just sulfur because it's this part right here that we're worried about with the IDE going away and being replaced with the name. So what is our element symbol for sulfur?
S.
S, perfect. Now we need to worry about our prefixes. So is there a prefix in front of nitrogen?
No.
Which means how many nitrogens do we have?
Just 1.
Just 1. That's the only time a prefix is not added for covalent compounds is if there is one of the first element. So I'm going to put a 1 here for now. This 1 does not need to be there later. I'm just going to leave it there for now before we combine things. What's this mono tell us? How many of those do we have?
1.
It's also a 1. The second element will always need a prefix no matter what. Second element always has a prefix. In the first element, has a prefix if the value is more than 1. So now when we combine these two, I'm going to get rid of those ones because remember, we don't need them. And so it's just going to be NS for our answer. Does anybody have any questions? I know this is a very quick recap of everything you guys learned about naming. Does anybody have any questions about any of it? All right, then, ladies and gentlemen, you have some practice problems down here. You first are going to identify ionic or covalent, and then you should either come up with the name or come up with the formula. Remember to watch out for prefixes are only on covalent. We need Roman numerals if we have transition metals in our ionic compounds.